Okay, so let's talk about something that at first glance sounds completely backwards. You've got Rust, right? The shiny, modern language built for memory safety, designed to fix all the old problems. And then you have C, the absolute legend of a language, but one that's known for being, well, a little tricky. So why in the world would somebody build a tool to take modern Rust and translate it back into old school C? That's the big question we're going to dig into. I mean, Rust is all about preventing the exact kind of memory bugs that can drive C developers crazy. It's supposed to be the future. Compiling it back to C feels kind of like buying a brand new Tesla and then trying to figure out how to hitch it to a horse. But as you're about to see, there's a really, really smart reason for doing this. So this whole story really starts with a problem that a ton of big software projects run into. We'll call it the modernization dead end. It's this idea that you want to use a new, better language like Rust, but the real world is messy and it just throws up all these roadblocks that stop you cold. And this is where it gets super practical. Think about a really important crypto library. It has to run literally everywhere. That means there's some person out there trying to get it to work on some obscure piece of hardware that only has a C compiler from 20 years ago. Or maybe a giant company has poured millions into security tools that only speak C. And don't even get me started on long-term support Linux versions that are going to be around for another decade. You can't just tell those people, hey, sorry, we're Rust only now. You'd be leaving them completely stranded. You're stuck. So if you can't just force everybody to jump into the future with you, what's the solution? Well, you build a bridge. And this is the key. It's not about going backward. It's about connecting the safety and the cool features of Rust with the simple fact that C is everywhere. It's about making sure nobody gets left behind. And that bridge has a name, Eurydice. It's a special kind of compiler, and its mission is super specific and really important. It takes your safe, modern Rust code, and it translates it into C. But here's the kicker, the part that makes it all work. It's designed to generate human-readable C code. This isn't just some jumbled mess that only a machine could love. It's C that an actual developer can look at and understand. And when you do this, you get some amazing benefits. First, it lets you switch over to Rust gradually. Your team can start writing new code in Rust today without cutting off all your users who are still stuck on older systems. Second, you only have one codebase to worry about, the rest code. That's your single source of truth, and the C version just gets generated automatically. And maybe most importantly, this whole process acts like a spotlight, showing you exactly who still needs that C version and why. It gives you a roadmap for the future. Okay, so how does this magic trick actually work? Because let's be honest, turning Rust's advanced features into clean, readable C is a huge challenge. So let's take a quick peek under the hood and see how Eurydice pulls it off. And this right here just says it all. On the left, you've got some nice, clean Rust. Pretty straightforward. And on the right, that's the C code that Eurydice spits out. Sure, it's a little longer, a little more verbose, that's kind of the nature of C. But just look at it. The structure is clear, the function calls make sense. You can actually follow the logic. It's made for a person to read, not just for a machine to compile. Now, getting to that clean C code is no walk in the park. The team behind Eurydice had to solve some seriously thorny problems. For example, in Rust, an array just acts like a simple value you can pass around. In C, not so much. So Eurydice has this clever trick where it wraps C arrays in structs to make them behave properly. And they go to great lengths to reconstruct the flow of the program so they don't have to use confusing goto statements, which is a huge reason why the output is so clean. All right, this is a really fascinating piece of tech, but is it just a cool academic project? Is anyone actually using this in the real world? The answer is a huge yes, and the names are going to be pretty familiar. First up, Google. They're actively using Eurydice to generate code for their critical crypto libraries. Now think about that. This isn't some side project. This is for foundational, high-stakes security code that has to be absolutely perfect. And it's not just Google. Microsoft is doing the exact same thing, also for their core crypto libraries. You know, when two of the biggest tech companies on the entire planet are both using the same tool for something as sensitive as cryptography, you know it's solving a very real, very important problem. But this real-world use is really just the beginning. The vision behind a tool like Eurydice is so much bigger. It's pointing to a future where we can take the best parts of modern languages and make them available to everyone, even folks on the oldest systems. And the project has a very specific,
And I gotta say, very ambitious target in mind for its next giant leap forward, and that year is 2026.
So what's the goal? Get this, to make the entire Rust standard library translatable into C. Just take a second to imagine what that means. All of Rust's powerful, super safe, and efficient tools, like its data structures and utilities, suddenly available to any developer working in the massive C ecosystem. It would be like giving decades of language innovation as a gift to the entire C world.
Which brings us to a final, really interesting thought. We always think of progress as this clean break, the new thing comes in and just replaces the old one. But maybe that's not how it has to work. Maybe the real future of modernizing all the software we depend on isn't about throwing out the past, but about building these kinds of smart, elegant bridges that connect it to a safer, better future.